Back in 2011, when I built my first CNC router, well, the only one I've actually ever built, which is this one, I used linear rails that were of the round type in it, and they served extremely well. These are from the Y-axis, and I used round rails for the X-axis and the Z-axis. In the time that I have had this and been using it quite extensively over the last, it would be 10 years now, I have upgraded a few things about it. One significant thing I upgraded some years ago was to rebuild completely the Z-axis. It was a little flimsy the way I originally designed it, so I actually used the machine itself, which is really handy, to remachine all the aluminium parts to make a far more rigid Z-axis. And more recently I have replaced the ball screws in it because the original ones were getting a little tired and a little sloppy. So I taught myself how to repack those and rebuild those. And also probably about 3 years or so ago, maybe 4 years ago, I noticed some grooves occurring on the Y-axis, which is supporting all the weight. So I actually replaced the Y-axis linear rails with just direct replacement round ones. But in more recent times, probably late last year, late 2020, I've always had the idea I wanted to completely replace the round linear rails with genuine HIWIN square rails. And I've now done that. And I did it in such a way that I didn't have to do any major constructional changes to the machine. I was literally able to machine up adapters to be able to basically slide these round rails out and install the HIWIN linear rails. And I'll give you a closer view of this after I've done the introduction, and also show you some pictures of how I installed the adapters. So originally I thought it was going to be difficult, but the main thing is that I found was that HIWIN rails have a much lower profile than what the round rails do. That they're round rails that I took out of this, and they're all the same type, they are 46 millimeters from the top to the bottom. Now the HIWIN linear rails, and I used heavier type for the Y-axis than I used for the X and the Z-axis, but for the Y-axis I used HGW 20s, and they're 20 millimeter wide rails, but the height of those, if I look this up, is 30 millimeters. So I was able to, as I already had a gap there, to take the round rails of, what did I say, it was 46, and I was putting the HIWIN rails in, which had a height of 30. I had some room to play with to be able to make adapters, so I used 10 millimeter thick aluminium to mount the rails on, and I used 6 millimeter aluminium to mount the blocks on, which then gave me a total height of 46 millimeters, which matched what this was. So it was a very, very simple process to use this machine again to make these adapters and literally do a direct replacement without having to do any other mechanical changes to the machine. So it's an easy process to do. When it came to the X and the Z axis, I used HGH 15mm rails for that, and they have a total height of 28mm from the face of the block to the base of the actual rail itself. So to do that, I was able to use, 12mm to mount thick aluminium strip to mount the rail on, and a 6mm adapter plate to mount the block on, and that then came into 46mm total height to actually mount the whole thing in. So what I did was I only did it one axis at a time. So I replaced the round y-axis with HIWIN rails first, got the machine all up and running, working properly again, and then a few months later I ordered and replaced the x-axis, got it all working again, and everything was going fine. The z-axis probably, it could have stayed the way it was with the round rails because there's no real load on it, but they were still getting a little sloppy, and I just didn't like the grindiness of these round rails. So I thought, well, I needed to have HIWIN rails all the way around. So I was able to make adapters up for the Z-axis as well, and I replaced that. So the whole process, I probably did it over about 4 months. But I did use genuine HIWIN rails, not the Chinese clone ones, and you can tell the genuine HIWIN rails, and I'll show you later in a still shot. They are laser engraved with HIWIN, and these came from, I think they're made in Taiwan. So it's a bit like chalk and cheese. When you've got a HIWIN rail, and I can't show you, they're already on the machine, but you can't just do that with it. It just won't. They're just really nice and tight and firm. They just give you a really good feeling, where these are, the round ones are a bit sloppy. Now you can tighten these up. There's a little grub screw in there to tighten them up and firm them up. But they tend to get, especially on the y-axis, which is taking all the weight, tended to get a bit of a, this has got a groove in it. This is the replacement one. It's got a groove where the balls rotate around and just sit on that one spot all over. And what happens is you tend to, because this machine only quite often works within that distance, you get a groove there and then you get nothing there. So it's sort of dipping. Now, for a lot of things, it doesn't really matter. And the machine was still working quite well the way it was. But being a bit of a perfectionist, as I am, and rather than building a whole new machine with HIWIN rails, I decided I could upgrade this machine, and I expect to probably get another 10 years out of it, and hopefully it's going to serve me well. I use it basically to CNC route acrylics, plastics, acetal, aluminium, wood. I don't do steel on it, but it does aluminium extremely well. And I've recently done a lot of aluminium on it. I've done up to 12mm thick aluminium, and it handles it really well. I use, it's a 1.5 kilowatt air-cooled spindle motor, VFD, running Mach 3, my own customized screen for Mach 3. And so, as I said in the introduction, I replaced the y-axis rails first and made the adapter plates. So I actually machined and had all the adapter plates made before the actual rails arrived, because I was able to download a fairly good drawing of where all the hole positions were and the heights and all of that. So you'll see that this is the 6mm adapter plate, and that mounts the HIWIN blocks. There is a 10mm extruded piece of aluminium behind that that the rail actually screws to, and the way the hole positions all work out, it's really nice because I was able to put holes and position them so that they are in the same position as the round rails, and then the HIWIN rail is secured right down the center with all of the holes. The HIWIN blocks, the position of the holes worked out so they don't interfere with the position of the holes here where the round rail blocks came from. So everything worked out really well. You can see here I used to have 2 blocks in that one there, but the HIWIN rails are a lot longer. So for this y-axis, I've got an extension here. So you've got one HIWIN rail there and you've got another HIWIN rail there. So that just comes out at the back, which works out really well because taking the central line down here, I'm basically supporting the whole gantry from this front face to this back face where it wasn't actually done before. So that's how the y-axis was done. The process of actually replacing the rails was really good. I put a support under here to block this up so that I could then unscrew all these holes that hold the blocks. I could unscrew all the holes that held the rail in, and basically just slid the round rails out in one piece. I had the HIWIN rails and adapters all put together and secured, and it just basically slid in, and I did all the screws up, did these screws up, and then obviously followed a whole positioning and alignment and tramming and all of the normal things you would do. So I did the y-axis first, similar process doing the x-axis, except these are slightly lighter or rails, and the blocks, and did the z-axis as well, and the whole thing came together extremely well. So yeah, that's how it's done, or how I did it, in a way that I did not have to change anything else about the machine, like the position of these or whatever. I was literally able to take the round rails out, slide in the HIWIN square rails, and it was a perfect match. Following doing that, it's just a matter of every time you're lining the machine up and making sure everything's running square and trammed and using dial gauges, the whole normal sort of process. So that's basically, my machine. It, I have a spoil board on it. You can see it's got a grid pattern on it, which is a lot fancier than what anyone could ever really need, but I'm able to fit a laser engraving attachment onto the spindle motor, so I was able to just play around and put lots of horizontal and vertical lines in. I mount most of my items onto here using double-sided tape, which serves me well and does really well. Even the aluminium that I machine is normally held to this with double-sided tape. I've got some holes screwed in if I need to add some extra support, but generally I'm a double-sided tape person. So there you go. I'll follow this up with various stills that will show you the adapters before they're actually on the machine here, so you can see how they're actually done, and give you a bit of an idea what the process is that I use to update my machine from round linear to square HIWIN. Well, that's almost it for this video. I hope you found it interesting and informative. It was my approach into replacing my round rails with square HIWIN linear rails. I'm really satisfied with the way it all turned out. The machine just feels a lot tighter and firmer than it did before. It sounds a lot cleaner in the way the axis moves, and I'm really confident that I'll continue to get really good use out of what is already an 11-year-old machine, taking me forward for quite a few more years to come. To give you an idea of what it all sounds like, if I just quickly demonstrate here, I will operate the Z-axis up and down. You can see, you can literally hardly hear that. It's just so quiet. And if I now go to the X-axis, and then to the Y-axis. Y-axis is slightly noisier because it's carrying the whole weight of the gantry, but the improvement over what it was with the round rails, I notice it, and I'm really happy with the way this whole upgrade turned out. So that's the basis of what I've achieved. So now some of you might be looking at this machine and just wondering about a few points that I want to cover. This hose here is for the dust extraction, chip extraction. I have various hoods that I've designed that fit under the spindle, attach with one screw, and the hood just goes down and secured it, and it all works really well. I made these myself. I made them all clear so that I can actually see what's going on by looking through it when the machine is operating, and also these slotted skirts, I suppose you'd call them. So that's the hoods that go on that. I also have made a touch sensor for setting up the Z at 0. That's 10 millimeters, and it's very accurately calibrated. It's also spring loaded, so that if something goes wrong and I see the tool start to press it down, I can immediately hit the emergency stop. That works really well, and it's literally why I'm able to set up my Z-axis so that I virtually never gouge into the spoil board. I come really close to it and I cut straight through, but I don't have to do that. It's got a couple of little blip marks on it there at the moment, but this spoil board has been down for many months now, and I've done a lot of jobs on it, and you can see virtually no marks on it whatsoever. So I'm just really pedantic about setting up my Z axis height absolutely accurately, so as I'd only have to change this board probably once a year at the very most. So that's basically the machine itself. What else is there? Yes. So I can also fit a rotary axis if I want. Moving that out of the way. So I've got a rotary axis system that I can fit to it for doing various jobs, such as A job I recently did was knurling these handles, which was in there. Also, if I take that off and out of the way, it's quite heavy. I can fit, where is it? Here. This is a 10 watt plus laser. Well, it's classified as 10 watts plus. I actually, it's a 7 watt laser diode, but I overdrive it so that it cuts really nicely, and that can mount up under there like that. Lasers coming down from this point here. I lose a bit of travel in that direction, and then the laser power box is attached to the back of the machine, and then these cables run up and under there. So that's how I actually laser engrave my spoil board, using the laser. I've also got another version of the laser which allows it to sit a lot higher, and then I can actually laser engrave and work on round material using my Rotary Axis as well. So that's it. And I have various hoods that fit under it, which also attach to the fume extraction system to suck all the fumes from laser work out the window. So that's the machine. These are closed loop steppers, 1.5 kilowatt VFD, still running Mach 3. I've got no reason that I've found to upgrade to Mach 4. It works really well, though I've created a whole set of my own customized screens. Keyboard, and under here, which you can't see, is the stepper control box, and all the laser power supplies and the laser controls, and the computer itself running Mach 3. As I say, I basically built this machine in 2011, which is just a bit over 10 years ago now, and it's served me extremely well. These side panels can come off if I don't need them. So there you go. I hope you found that little bit extra interesting as well about the machine itself and how it all came about. Thank you.